Hi guys, so we're going to go over the important ideas for today's lesson. In the first one, you should have some type of outline similar to this for those two treatments. Remember that we start with our experimental units. We always want to randomly assign. Remember that random assignment is what allows us to, in the end, say that one thing causes the other. It gets rid of, or lessens at least, those confounding variables that could play a role in SAT scores. So if I randomly assign people, it's equally as likely that they would have gotten one class or the other, and so therefore it allows me to look for that cause and effect, or causation. So I've got my random assignments. Remember, we want our two groups to be roughly equivalent. So hopefully you've got 25 in each. We're going to then apply the treatment to them. So we have two treatments in this experiment, the online class versus the teacher prep course. And in the end, we are going to compare those SAT scores. This experiment is what we call, and it says it even right here, but let's just write it again, a completely randomized design. So this is just a completely randomized design. Then going on to question 2. Hopefully you came up with something like this. And if yours is a little bit different, just listen to the big ideas and make sure that you've at least hit these certain marks. So now I want to compare juniors and seniors. I want to make sure that I have an even distribution of those two grade levels in both groups. And so what I'm going to do is take all 50 students and break them down into two groups based on grade level. And this might remind you a little bit of like a stratified sampling that we've done before. But now that these are experiments, we actually call them blocks. So in this example, we create two blocks, a block for seniors and a block for juniors. Remember, this is not strata. So when you are doing experiments, we always call this a block. When you are doing sampling, you call it strata, but we cannot interchange them. And then once I create my blocks, I basically do a completely randomized design for each of the two blocks. So I go through with the seniors and I put them into random assignment. And then I go through each group, the grouping for them, assign them their treatment, and then compare their scores. Do the same thing for the juniors. And then in the very end, I fully compare both of their scores. So this is what we call a block design. All right, now in the last one, this one might have been a little bit harder to design exactly in the manner that I have it. But let's read what I've got here. So what I said was put the juniors in order from highest to lowest GPA. Take the two students with the highest GPAs and pair them together. Flip a coin to assign one to the teacher class and one to the online prep. Repeat this process until the next two highest GPAs, with the next two highest GPAs until all 30 juniors are assigned a course. So in this example, what I'm going to do is pair these students directly. I assign one person to one treatment, one to the other. And then when I come back to compare scores, I am going to compare the pairs directly. So if you and your friend have the highest GPA, the two of you are going to be split up, go to your two separate courses. And then when I am comparing results, I'm going to compare the two of you against each other. So that way I can see how people with high GPAs directly compare with their development and score development through these courses. How did they do? Did they do better? Did they do worse? Did they do the same? So in this example then, if I have 30 juniors, what's going to happen is I'm going to end up creating 15 pairs of students. And essentially, this is kind of a block design. It's just that now I have 15 blocks and each block only has 2 people. So in a paired design like this, it's very similar to the block. You go through, you take your 2 people, you give them a random assignment, they go and do their treatment, and I compare their scores to each other. In the end, I could compare everybody's scores just to see overall results. This is what we call a matched pairs design. All right, so we're going to move on to the important ideas. If any of that was confusing to you, just let me know. I'd be happy to go over it again. So for our important ideas, I'm going to break up my box into 2. And I'm going to start with talking about the block design. So let's first define what a block is. A block is a group of experimental units remember, that's the who or what that we are applying the treatment to. And it's units that are similar. So we can think, if we're thinking about strata, what word does this relate to? Homogeneous, right? But in this example, we call it a block. We want groups of experimental units that are similar. And I would create a block if I wanted to do a randomized block design in my experiment. All right, for my randomized block design, what do? I separate the subjects into blocks, and then randomly assign treatments within each block. So we create our blocks of specific groups, and we create them on purpose because we think that that characteristic will play a role in the results. So I don't just do this because I want to. I don't just do a block design because I have juniors and seniors. I do it because I think that juniors and senior grade level will affect their SAT scores. So because I think it will play a role, that's why I would want to do this design. I don't just do it because I have different groups. All right, then we also have the example of the matched pairs design. In a matched pairs design, the experimental units, I'm just going to call them the subjects, are paired, and this is kind of like a block size of 2. So they are paired and then randomly assigned to a treatment. And in this example, because we have only a block size of 2, there's only 2 people in a pair, it's pretty easy to say, like, just flip a coin, right? I don't have to go through the whole randomizing process. Flip a coin, that's pretty easy to do. And then here, each subject receives 2 treatments. And we'd say that order of the treatments must be randomized. So for the second one here, this is actually kind of a different approach to a matched pairs design. So in the first one, each subject is paired and they are randomly assigned to a treatment. So this was what we just did, where one went to the online course, one went to the teacher prep course. But in the second one, this is where each subject receives 2 treatments. So for an example here, we might say that we want to experiment to see which of these 2 types of, I don't know, let's say pens people prefer to write with. So in each pair, you are going to receive both treatments. You get to try out both pens and see which one you like, and then I can compare the results of which one you prefer with the one that somebody who is similar to you, who I've paired you with, prefers. So where you both get both treatments, and then we can compare the results of what you prefer. And either way, order of the treatments must be randomized in this one. So basically, whether I give you the gel pen first, or if I give you the regular ballpoint pen first, that's going to be randomized for you and your pair. All right, so why don't you move on to the check your understandings and see if you can apply what we learned today.